Hello there, welcome back to Chemisphere channel. I am Chandan Biswas and today I am going to teach you how to balance redox reactions. Redox reactions are real trouble. It's too much messy because here don't you have to only take care of the atoms to be balanced but also the charges, and also you have to take care of the medium in which it is getting to be balanced. So let me ease that out for you and tell you one of the greatest and easiest way to handle balancing chemical redox reactions. Finding the oxidation numbers is the only prerequisite we need to understand this method. So once you know how to do this, now we can proceed with step number 1. The first step is to write the equation in ionic form. Let's say this equation is FeO plus KMnO4 plus HCl equals FeCl3 plus MnCl2 plus H2O. Now this is the equation and we have to convert this into the ionic form. In ionic form, this entire equation will be written as FeO plus MnO4 minus and H plus equals Fe3 plus Mn2 plus H2O. So we see that we only are interested with the ions here, not the molecule by itself. Why are we doing this? You will know in a while. The next step is to write down the oxidation numbers of the critical elements. What are the critical elements exactly? Critical elements are those elements which are actually undergoing oxidation number change from the reactant to the product side. Here we see that Fe has an oxidation number of +2 which becomes +3. So this Fe, which is iron, can be treated as a critical element. Similarly, MnO4 minus, we see that Mn has a +7 oxidation state and it becomes Mn2+. So Mn is the critical element here. We have to balance them. Fe on the LHS and Mn on the LHS are equal to the same number of ions on the other side. So therefore we don't need to do anything in this case. The next step is calculate total increase and decrease in OS. What do I mean by that? We see that FeO, where Fe is in +2, becomes Fe +3. The change in oxidation state will be +1. Similarly, MnO4 minus, where Mn is in +7, it becomes Mn +2, which means there is a decrease of 5 oxidation number units. The only goal to do this is that we have to make sure the number of increase becomes equal to number of decrease. So therefore, -1 has to be equated with +5. How do we do that? We can do this by multiplying this +1 oxidation number with 5. When we do that, we see that the entire increase becomes as +5, which is equal in magnitude with the -5. As we multiply this 5, we have to multiply all the elements which are undergoing this process, which means 5 has to be multiplied in FeO and 5 also has to be multiplied in Fe3+. Now since we have balanced this and we have equated the increase with the decrease, now we can proceed to balance the charges. On the LHS, there is 1 minus charge. On the RHS, we have 5 into 3 plus, which is 15, and 2, which is 17 plus charges. Now these need to be balanced. How do we do that? In acidic medium, we balance charges by adding H plus on the required side. Whatever plus charge is deficit, you just add H plus to that side. That is how we balance in acidic medium. If you want to balance the equation in basic medium, then go with balancing with OH minus ions. OH minus ions carry a negative charge, so that can be added to the required side wherever you need it. Let's say in this question we have to balance with acidic medium. What should we do? On the right hand side, we see there is a deficit of 18 plus charges. So we add 18H plus to that side. While adding this, we see that we are also increasing hydrogens. However, the charge is already balanced. As you can see, in the LHS we have 18 plus and 1 minus, which means 17 plus charges. And on the right hand side, we see that there are 15 plus 2, which is 17 charges. So that is fine altogether. Now we have introduced some hydrogens here. We have to balance them as well. Whatever the number of H plus you are going to add or OH minus you are going to add, you have to add the half amount of that H plus or OH minus as H2O to the other side wherever you have added. For example, we have added here 18H plus. So half of it, which is 9H2O, that has to be added to the other side of the equation. That makes us this equation. So that's it. That's all is required. And now you can see that the equation is already balanced. 5FeO plus MnO4 minus plus 18H plus equals 5Fe3 plus Mn2 plus 9H2O.
Now you can add K plus and 18Cl minus ions to both sides of the equation and club them together to get this final equation as this one. This gives us the final balanced equation.
So in 6 small steps, you are able to complete the entire thing. Let us show you another example for this, but this time in basic medium. We have this equation Cr2O7 2 minus plus SO3 2 minus becoming Cr3 plus and SO4 2 minus. We write on the oxidation numbers over here like this. We see that the critical element is chromium, so this is 2 on the LHS but only 1 on the RHS, so we balance that out. So this will be 2Cr3 plus. Now once we have done this, we see that how much of increase is there. From Cr2O7 2 minus to 2Cr3 plus, it is a decrease of 6, and from SO3 2 minus to SO4 2 minus, it is just increase of 2. So what do? We multiply this side with 3, which means that the increase becomes equal to the decrease. So once we have done that, we see that how much of charge is there. So on the LHS, we see that there are total of 8 minus charges, and on the RHS, we see that plus 6 and minus 6, there are 0 charges. So to balance that, we add OH minus to the other side, which is 8 OH minus, and whatever amount of OH minus you add to the other side, half of that has to be added on the other side, which means 4H2O has to be added on the other side. And that's it. The reaction is already balanced here. The more you practice, the more second nature it becomes for you. So try this method out and try to solve more redox reactions and balance them to see this method works or not. It will take only a minute, less than a minute, I guess. It is quick, it is effective, and I highly recommend this method to you guys. And that's it. That much I have for you in this video. I hope you enjoyed this video, and I hope redox reactions will be easier for you from now onwards. If you like this video, do give a thumbs up on the video, and do not forget to subscribe to Chemisphere channel and share it with your friends. The more you share it, the more people will get suggestions, as that's how the algorithm of YouTube works. So please help me out, because we are growing as a channel and really need your support. So do not forget to give a thumbs up on the video. I'll see you in the next one. Bye-bye. Learning chemistry can be boring, but what if I said that this subject has the best chance to increase your scores in your competitive exams? Luckily, there is a way. Hi, I am Chandan Biswas, and I am a professor of chemistry, and I have the honor to groom 15,000 students appearing for JEE, NEET, and class 10th and 12th boards in the last decade. I know inside out of these exams, and I'm going to help you this time. I'm going to help you on each step of your journey towards clearing these competitive exams. You will find the most cutting-edge resources for your studies, including neatly made notes, and also the best knowledge resources for your curriculum. There are customized classes to suit your needs. Also, you are going to get a lot of video and text resources, which will probably make you fall in love with chemistry once again. You will also be able to track your daily progress and weekly progress through monthly and weekly tests. So, DM us right now or WhatsApp us to book a free demo class today. I'll see you in the class.